Missed. AI is in the air.
Thank you for joining, everyone, and welcome. It's going to be exciting. Actually, but there you go. We'll start with, the Wi-Fi is slow. Where do you start, and how do you go about it? Then we'll go through, hey, I can't connect to the network, right? So, it works at home. What's your problem? Number three, it intermittently drops even when I'm not moving. It's a very, very common problem. We're going to look at that. Number four, voice and video calls are choppy and dropping. What can attribute to that? One of my devices doesn't work, right? A lot of people, come to the corporate office and say, my corporate devices are okay, but I can't get this phone on the network. And then, there's only one or two bars, people complain that they have coverage issues, and then there is roaming issues. Beautiful. If you can keep voting, I would appreciate that. So but without further ado, let's get started on the number one issue that you guys have voted here. So let me get rid of these things here. Beautiful. So this is the Missed dashboard. And what we've done to fundamentally understand the user experience is we've started to measure the experience from ground up, right? From the user up. Only then can you get down to, hey, why is the Wi-Fi slow, or why is somebody not able to connect, right? So now let's look at what are the top problems that you guys have voted. The top two problems, and by the way, this is universal, right? Not isolated to any of you that just voted here. The top two problems are, I can't connect to the network and my Wi-Fi is slow. So let's dissect those. If you cannot connect to the network, what could it be? It could be because your Wi-Fi driver is incompatible, because you have an old device that is using an old encryption. If you have a device that is capable, but DHCP is not accepting any new clients and assigning IP addresses. You could have a radius mismatch. You could have the wrong password. So all of those we summarize into your ability to connect. Are you able to connect to the network? There are other reasons why you can't connect to the network, and those are, it takes too long to connect because the client driver is slow, the DHCP server is overloaded, the radius server is overloaded. All of those things we categorize under time to connect. And then there is roaming. Roaming is, hey, my connection drops when I'm walking, or I'm sitting in one place. I don't know why this goddamn thing is actually flapping between APs, but it is part of roaming. It is part of connection, right? So what we did is we take every user, every session that the user ever has with the wireless network, whether it's an AP or multiple APs or the entire network, we collect, collate, and curate and run AI on it, right? So this is the problem number two that you voted. But problem number one, you said, is, why is my Wi-Fi slow? Why can't I get the throughput that I want to get? So then what we did is so what could it be? When the Wi-Fi is slow, when the application experience is slow, what could it be, right? All of you are smart engineers on the call. And so here's our perspective on what it could be. Number one, is the device capable of good performance, right? Meaning if you're using 11B device and expecting 100 megabits, that's not going to happen. We characterize that. We take every device and we maintain a global profile for that particular iPhone with this particular iOS version, blah, blah, blah. And we characterize and we come up with the capability of the device. Let's say the device is a brand new MacBook Pro you just handed to your CEO, right? And he's not getting 100 megabits. What could it be? It could be coverage, right? It could be where he's sitting in the corner office and there's not enough coverage. So every user, every minute, we take their average RSSI and we will tell you what the coverage experience is. If coverage is not good, then you won't get good performance. So here we are able to factually tell you 87% of the time, we are delivering better than x66 dBm for our users, okay? But I'm going to show you much more deeper after this. So coverage. So number one, device capacity. Number two, coverage. Number three, let's say I have a brand new MacBook Pro. I'm sitting right under an access point, right? Now, if I'm sitting right under an access point, coverage is great, but I'm not getting 100 megabits. What could it be? It is capacity, right? It could be that the Wi-Fi has a lot of interference, or the Wi-Fi has a lot of neighbors that, there could be non-Wi-Fi interference, or it could be Wi-Fi overload from our neighbors, or it could be Wi-Fi overload because somebody sitting next to you is downloading Mac OS Sierra update or an iPhone update and hogging all the bandwidth, right? So it could be Wi-Fi or non-Wi-Fi interference, neighboring Wi-Fi interference, or your own AP load. Capacity matters. So device capability matters, coverage matters, capacity matters, right? And so every user, every minute, we take the average available capacity on the channel and we say, what percentage of the time are we delivering, at least 10% available capacity on the network? In our office, we're saying 95% of the time, we're delivering at least 10% available capacity. Now, let's go look deeper. Capacity was good, and I have a brand new MacBook Pro, meaning I have a MacBook Pro, I'm sitting right under an AP, and the channel is as clear as a clear day, right? Now, can I get 100 megabits? Well, what if the wired network and the WAN is saturated? So we factor all of that when we do and predict the throughput estimation for a user, right? So let's start with the first one, coverage, right? So first, let's say we are saying in our office we're delivering, better than 85% coverage. Now, what is that 15%? Why are we not able to deliver 100% great coverage? By the way, we are setting, neg 66 dBm, which is a pretty good high bar. It's a good bar for voice and that kind of stuff. And so here we're saying, you know what? I can tell you if the coverage is bad because there is uplink asymmetry, meaning I can hear the client and the client can't hear me. There's downlink asymmetry where, let's see, the AP hears the client weak, and then uplink asymmetry is the AP hears the signal, weak, but the client hears the AP signal just fine, right? This is the most common cause of asymmetry. What is asymmetry? Meaning I can scream as an AP, I can scream at maximum power, but the device may not have enough power, right? So uplink, its packets are not reaching us. So that's not good. We need to reduce the shrink the cell size. And we do that, and I'm going to show you how we do auto RRM around that. Then we have downlink asymmetry, where the client doesn't hear the AP good enough, but the AP hears the client well. Usually it doesn't happen. That's why it's not very prevalent. And then there's weak signal, period, right? I mean, the client is hearing, there is no asymmetry. We are hearing each other at almost the same signal level, which is weak, right? So great. Okay, so coverage is 85%, but how do we know who is it affecting? When is it affecting? Where is it affecting, right? How do you go fix this, right? And so here we go. We're saying, okay, our coverage is 85%. On average, we're doing a very good neg 58 dBm. By the way, a lot of you are fans of Site Survey. Some of you may be partners who do Site Survey. Site Survey, I'm sorry to say, is a point in time and is obsolete the moment you walk away from that site, because Wi-Fi is a living, breathing organism. It's unlike every other network element, right? Because if your neighbor suddenly brings a bunch of video cameras, your wired network is not going to see them, but the Wi-Fi is going to be affected. Wi-Fi is a living, breathing organism, right? And so consequently, we are doing a continuous site survey of your system here, unlike any other system ever in the wireless industry, right? And so now I can tell you exactly how and when you're seeing these uplink asymmetry, downlink asymmetry, and weak signal on the Wi-Fi. By the way, who is it, what type of devices is it affecting? Which access points are serving the worst coverage? Where are those access points serving the worst coverage? Obviously, ours is a test system. Don't be freaked out by, we're a Wi-Fi company and can't build a freaking Wi-Fi network. We trash our network too much. But, you can see exactly where a particular device is serving bad wireless users, right? The missed Marvis AP, which is one of our conference room APs, it's basically telling us, every client that connects there is having worse than neg 66 dBm. Then I can get down to who's having bad coverage, right? Basically, it's saying, Leah's iPhone here, 100% of the time it's connected, is actually getting worse than neg 66 dBm. First time in the industry, guys. First time in the industry, we can tell you who's having bad coverage and who's having bad coverage because of a certain type of asymmetry or weak signal, which APs are they connected to. Okay, so understanding why is my Wi-Fi slow starts with coverage. Then with capacity, similar exercise, how are we serving capacity? What type of devices and APs are the worst affected? Where are those guys located from a capacity perspective? And then who is it affecting, right? But this is not the complete story. And so that's why for answering the question, why is my Wi-Fi slow? We turn to throughput. This is our composite metric here. We fuse here, is the device capable? Are any of the devices at the missed office incapable of delivering, a 20 megabit channel? Then, is coverage good? Is capacity good? As you can imagine, because as a Wi-Fi company, we're crashing our RF constantly. This is the primary reason, our capacity is the primary reason we're not able to deliver good throughput. So for the first time in the industry, you can before the user calls you, whose Wi-Fi is slow, right? And, so you can go down and see, and if you want to fix any of these guys' problems, whether it's coverage, capacity, again, if it's capacity issue, then you know what to do. You add some APs, but I'm going to show you how our radio resource management helps you optimize and reduce and a lot of this, right? This is something that is claim to fame for us. Now, this is the manual way of doing stuff, right? Now, if you said, hey, I just want to know unhappy users for throughput in the missed office, I'm going to pick our corporate office headquarters. You know what? I'm going to go into a full screen here and pick our corporate headquarters. Boom. This is essentially the answer here is, these are the users that are having Wi-Fi performance issues. Quite simple. Simple question. And by the way, if you've never seen Mist, we have a virtual assistant called Marvis. Marvis is our intelligent AI assistant. And so Marvis, you just ask the question, Marvis, who's having throughput issues? Who's having Wi-Fi slow problems? Before the users call you, Marvis can tell you, right? And now let's say, hey, I want to understand why Kwong's iPhone is having issues. I can go down and troubleshoot his individual device, right? And here you go. It's telling me, hey, he's having throughput issues. He's also had some time to connect issues, but his throughput is primarily because of low RSSI, weak signal, and wherever Kwong is sitting, he's having some challenges with it, right? So you can go down and say, tell me more. Present the FBI case file on how did you arrive at this conclusion, right? So we're now diving into Kwong's individual iPhone for today, and I'm telling you, and I can do this over 7 days or whatever. or actually a very, very specific time interval. If a user calls you and says, you know what, last Wednesday at 2 o'clock, we were in the board meeting and all of our calls dropped, we can tell you exactly. So we know what the issue is. We know how Quang's device stacks up relative to other devices, which operating systems are the worst affected. And if all else fails, you can see exactly, what type of events Quang is having, and is he crashing the network, blah, 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 right? So Wi-Fi is slow. I showed you so far 3 things, right? How do you track coverage issues? How do you track capacity issues? And how do you fuse that into the throughput? What if it was, what if this was the WAN, right? What if it was what about the rest of the WAN, right? How do you understand if network issues? And I'm going to get to that momentarily. Essentially, we basically let you see, how your WAN latency and jitter are doing, right? So okay, so let's move on. So we also have a way where we can actually tell you that it is latency and jitter and so with what we call the network SLE. So we got the coverage figured out, we got the latency figured out. Now I can tell you with this network SLE, how is the latency on the WAN, how is the jitter on the WAN, are there any Ethernet issues on the wired side that are causing this, right? So Wi-Fi is slow. I think we can solve a lot of this. However, what I haven't done and what I haven't shown you is how does AI automatically fix this, right? For that, I'm going to show you one slide of theory, right? And so the one slide of theory on how does AI fix this is we launched the world's first AI-powered RRM. And this is what will fundamentally change the way you've ever deployed and thought about RRM. Again, another small backstory. The CTO of Microsoft, Kevin Scott, over the Thanksgiving break, he was doing a session or whatever, and he talked about there are 2 technology trends that will fundamentally change the way we live, work, and play going forward. And the number one technology is how we're building smaller and faster chips, right? And so, eventually we'll all have chips in our bodies, and we'll be, we'll be scanning ourselves continuously, blah, 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 right? Number 1 is hardware. Number 2, he said, number 2 technology trend that will fundamentally change how we live life as we know it is reinforcement learning. If you don't know what reinforcement learning is, obviously Google it, find out. I'm going to do a 30-second explanation of what it is. Reinforcement learning is the notion of, the AI agent takes the data, takes an action. So what action does RRM take? It generally changes channel, generally changes power, changes the channel bandwidth. These are a few of the things that RRM can do. Once we make that change, then the environment, which is our ambient RF, is affected, right? So we improve the coverage for people. Maybe sometimes we don't. We improve the capacity for people. Maybe sometimes we don't. So what is reinforcement learning? Reinforcement learning is the notion of observing the environment after we make the change and see how the client capacity utilization has gone, how the coverage and SLE has gone after that, how the user experience on the client data rate is, with respect to symmetry, how roaming is. We observe all of this on a per client, per minute basis for 24 hours. Every client, every minute, 24 hours of data. And then we come back and continually tweak, right? First time in the industry. No controller in the world has ever had the memory, CPU, and wherewithal to run AI algorithms like this. And this is why your next generation network should not be a controller-based architecture that's built on boxes. You should build your network on a microservices cloud. But that's for a different day. I'm going to spend some more time on that later. But AI-driven RRM, this is how you take action on my Wi-Fi is slow. And so now let me show you what that looks like in a sort of a real world scenario. What we have launched with RRM is we've launched a few metrics, right? With our RRM, I will tell you exactly what the density of the APs is. Why is this interesting? Let's say you have 20 different sites all over the country or all over the world. How do you know if you have the same level of density in all these places? How do you know what's the average number of neighbors that your APs hear? Obviously, in Mist, it's too much. But in most of our customers, you want an average of 2 to 3 neighbors that every AP should hear. That means when an AP goes down, you have alternate redundant coverage. This metric, by the way, ladies and gents, never been done in the industry, never exposed properly. We're telling you what the average neighbors are for your RRM neighbors, radio resource management neighbors. What is the average noise level, average co-channel neighbors? You don't want too many co-channel neighbors. You actually want adjacent channel neighbors or alternate channel neighbors, right? And so average channel. So this is what is fundamental and foundational when it comes to basically knowing how is your network doing, right? So here's an example of an AP that all of the Mist APs have a dedicated third radio, right? We have a dedicated third radio. And so now here I chose the Mist Boardroom AP. Its third radio is telling me that this is the channel occupancy of all the neighboring channels, all the Wi-Fi channels on the 5 gigahertz band for that particular AP. So every AP in the Mist universe is hearing all the other APs, right? So now here I'm telling you, hey, I picked channel 124 and 128 because they are the least loaded 40 megahertz channel, right? So and every other channel is either occupied by non-Wi-Fi interference. Sounds like we have some of that on channel 140 here, or other APs interference from our neighboring APs or our own APs, right? So anyway, sorry, I was still, in problem number 1, we probably have to do 5 sessions around this, but the point is the AI-driven RRM will take care of your slow Wi-Fi issues. That's number 1. I got to speed up. Number 2, the next problem we want to solve is, why can't I connect to the wireless network? At the beginning of this call, we talked about when you can't connect to the wireless network, there are only a few reasons, right? There's probably just 150 reasons why you can't connect to a network. Truly and honestly, I've been in the industry about 20 years now. My master's thesis was TCP performance over wireless about 20 years ago. So there is one way to connect to the wireless network. You associate, you authenticate, you get DHCP, you get DNS, and you're off to the races. But there is over 150 unique states in which you can not connect to the network. We collect, collate, and curate all of those states. So let me walk them that lane with you. Okay, 99% of the time today, our users are able to connect to the network just fine, right? But then, what is that 1%? What if that 1% was the CEO and the board meeting or the provost or the dean? Then we will tell you without a single click here, you're still on our primary dashboard. We will tell you exactly what is happening, whether it's DHCP or radius or Wi-Fi or whatever. And then you follow the same trail, right? So, when did, failure start? Who is it affecting? What type of devices is it affecting? What type of, device types is it affecting? Which APs are serving the worst clients? All that kind of stuff. And then you can go in to say, hey, Osman's Apple Watch is having an issue. You can click into Osman's Apple Watch and then go and see, all the ways in which that device is not able to connect to the wireless network. What is happening with his Apple Watch? And by the way, whenever there is a catastrophic failure, we have a dynamic packet capture in the cloud. So never ever do you have to say, hey, can you go walk the hallway again so I can take a sniffer trace? Passe. Do not deploy a wireless system that requires you to ever walk out to the end user the end user site and take sniffer traces. Don't do that. That's like buying a Garmin GPS system from 15 years ago. That's your controller, guys, right? The modern cloud systems don't let you do that. And oh, by the way, if you're wondering, if you're a large higher ed campus, if you're a large university campus, if you're a large enterprise campus, and you're wondering, wait, the cloud systems I thought were for all my distributed branches because I centralize my traffic in these campuses. Is the cloud really for me? Can I actually deploy this in a 6,000 AP contiguous campus environment? Ladies and gentlemen, I'm here to tell you, you can without changing your network architecture. That will take us down a whole another 30 minutes of presentation. But if you're interested in that, if you're a large campus, if you want to know why 3 of the Fortune 10 companies, we're not talking about Fortune 500 companies, 3 out of the Fortune 10 companies have now standardized on Mist for their next generation wireless. One of the customers has 270,000 APs from Cisco, and they're just sending us a purchase order for about 15,000 to replace and start replacing. And they believe Mist is their wireless for the next generation. Another customer has 90,000 Cisco APs, and they've already deployed about 6,000 from Mist, and they're taking down the rest of the network. This is the future. And with respect to higher ed, we just won Dartmouth College, 6,000 APs contiguous space. And they're a reference. If you're interested, reach out to them. They're interested. If you're thinking healthcare, if you're a healthcare company and want to understand if the cloud is right for you, talk to the largest healthcare institute in the country and in the world, the VA, and they're just moving to Mist. So, sorry, small public service announcement. So you talked about 150 unique ways in which you can fail. Here we show you about 30 or 40 states you can fail, but we actually collate about over 150 unique states for why can't my user connect. Okay, I'm going to run out of time, but I'm going to do one more, and I think let's go back and see what was our third most voted one. Wi-Fi drops intermittently even when I'm not moving, right? So this one actually candidly goes the very similar route of, why can't I connect, and by the way, we have we maintain every 2-second transitions for clients. So we can tell you exactly when clients are roaming this way and that way, what data rates were as they were moving in and out. And so we haven't talked about this roaming SLE. So let's talk a little bit about, hey, my call drops when I'm roaming, or I'm sitting here and I'm flapping between clients, or intermittently my connection drops, right? So what we do for roaming is we characterize, are you capable of fast roaming? Are you capable of 11R and you're doing a slow roam? Are you only doing standard roams? Are you capable of opportunistic key cache roams, but yet you're taking too long to do those roams? Are you failing to fast roam when you are 11R capable, right? When you're 11R capable and not doing 11R roam, or when you're 11R capable and taking too long to do 11R roam, we collect, collate, and curate and characterize all of this, right? So you can go back and ask Marvis, you can go back and ask Marvis the same exact question. You could say, Marvis, show me unhappy users for roaming, right? And they'll say, okay, which office are you talking about? And actually, looks like they're happy and healthy today. So let's expand the search to the last 7 days and see who was having roaming problems. We feel like this one particular Android is having some roaming issues, right? And there's a lot of interesting troubleshooting things you can do from there, right? So that's I'm well over the 30 minutes that we promised we will take from you. We haven't shown a few more interesting things around what the product can do in terms of troubleshooting. So if I may summarize, we talked about why clients can't connect. in our world, that boils down to successful connect SLEs and time to connect SLE taking too long to connect, or roaming SLE. We talked about why Wi-Fi is slow, coverage, capacity, device capability, latency on the WAN, jitter on the network, and Ethernet problems, right? We collect, collate, and curate all of that, and we present to you as one throughput SLE. We talked about connection drops while walking. That's the roaming SLE. We talked about why video and voice calls are dropping. That's also, encompassed in the throughput and the roaming SLE, and coverage hole detection and everything with those bars. Mary Kate, are there any questions that I should address? I have a couple more slides I wanted to do if you think I'm still okay on time.
I'll tell you what, why don't we take a couple questions, and then anybody that wants to stay on can, and if not, we'll send out the recording after. Sound good?
That's good. Can you call out the questions if they were in the chat window?
Yes, I can. So I have one question here that we'll just do to start. Someone says, hi, Sudheer. Does this tool offer analytics into WAN links, utilization, and suggestions for appropriate actions to increase bandwidth? So streaming services that affect WLAN. I think he wants to know how granular the reporting is looking into the WAN.
Yeah, so good question. And actually, let me take that specifically, and then address one thing we're doing with some of our AI for IT partners. So what do we do for the WAN, right? We are constantly telling you, because here's our strength and opportunity, right? Our strength and opportunity is we have a link to our cloud at all times. So that means our APs are constantly talking to our cloud. Oh, by the way, we don't take too much bandwidth. I have 13,000 APs at PetSmart, and every one of them all run on T1 links, right? And never had a capacity issue on their WAN caused by us, right? We heavily optimize. But every one of our APs is constantly talking to the cloud. So literally, we catch and we caught at PetSmart as an example once, when their corporate WAN was down, our SLE caught that before they even actually saw that on their own side. And so the way it works is basically we're telling you, when do we see latency issues, right? And when do we see Ethernet errors and jitters? A very interesting example. We just won the largest specialty retailer in the world. They have 25,000 Meraki APs, and now they're switching to Mist. About 6,000 are being deployed as we speak. And they rolled out a new update on their router, okay? And the moment they rolled out that update on their router, their successful Connect SLE was actually affected, right? And then we have anomaly detection because we baseline everything. We baseline and we are watching for anomalies, right? So then I'm actually going to show you the anomaly detection screen here. Hopefully I have it. I did not have it. So, but anyway, let me actually come back to that. We were able to catch that our successful connects was dropping. We alerted the customer, right? And they're like, hey, okay, interesting. So let's go look at it. Turns out, long story short, they pushed a router upgrade, and that router upgrade was dropping large packets, and hence the particular authentication certificate-based authentication was failing. So we catch a lot of WAN issues. But where are we headed with this? Where we are headed with this is we launched a partner program with Juniper and VMware VeloCloud and Versa and some of the other SD-WAN router companies. And they are sending us their stats via API, and you will see on this timeline not just our charts, it will actually show you what we're working on. But basically, once you go to the WAN SLE, you will start to see in the in the timeline, you will see exactly which WAN link it is that was causing the issue, when was it causing issues, and what was the latency and jitter. So we are launching an integration with many of the SD-WAN providers that will give you that answer directly. Sorry, long-winded answer, but the answer is yes.
So the next question here is, how long does it take RM process to react to high device/high user density locations that suddenly shift from high density to low and back and forth?
So we have transient reaction in a matter of minutes, meaning if the capacity SLE suddenly went through the roof, we don't wait for 24 hours to react to it, right? So we are monitoring this capacity SLE continuously. If the load goes high and the channel is unusable, we immediately change channels. Matter of minutes. I think 1 or 2 minutes. I have to get the exact answer, but it's in a matter of minutes. But with respect to planning for the overall and learning the new baseline, when students come back and now the ambient RF is much more highly utilized. By the way, we have a lot of dorm room environments and that we've deployed in very successfully, and high density deployments we've done. We collect this data over 24 hours, and then we react at a global scale. The 24-hour metric is around optimizing capacity across the entire AP space at that site, optimizing coverage across the space and optimizing, throughput, right? So that optimization is over 24 hours, but obviously, like any enterprise system, if you need some instant reaction because somebody is blasting the channel, that happens in a matter of minutes. Okay. Let me actually show you one other thing, right? So a lot of times, customers come to us and say, hey, we would like to get ahead of the problems, right? Instead of waiting for users to call us. And that's what this is. We launched Anomaly Detection, so we know when things go bad. And today in the Mist universe, we alert our customers when there is anomalies before even the customer calls us. Our support starts looking at anomalies before even the customer calls us, right? So when there is an anomaly, you can zoom in and say exactly what was happening at that particular instance at that particular time, right? And then again, our whole thing is when it is your time to troubleshoot, we have the entire case file presented to you in one screen, right? And so when it is anomalies, and I go to the anomalies screen, I know, okay, there are some anomalies here. Then what I want you to do is all you need to do is click the investigate button, right? Once you click investigate, we're going to put the entire case file together for you, right? We will tell you how many clients were affected, what percentage of their connections are failing, which APs are they failing on, which WLANs are they failing on, when did they start failing, right? Is there a user action that caused it? Was DHCP involved? Was DNS involved? And who did it impact, right? This is the hardest thing, right? When your network went to hell in a handbasket, who exactly should you expect a call from that did not call, right? So that you can proactively reach out and message to them saying, hey, we had an issue and blah, 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 right? So when all you have is, if all you had is these set of clients that were impacted and those are the guys that you need to reach out to, you're much better equipped, right? And basically, once you have this entire case file ready for you, we want to see, did some administrative change cause this impact? A lot of times, somebody touched config and suddenly, they inadvertently changed the profile or the template or the config, and that's what caused it. So you want that to be collated with you. And when we do our AI for IT integration, we want to be able to bring the other system changes into this process as well. Okay, all right. So that's anomaly detection. I am well over time. was the slide I wanted to finish on. Mist is actually is seeing tremendous success in the marketplace. Again, as I said, in the Fortune 10, 3 out of the Fortune 10 are deploying Mist, standardizing on. We're taking names in higher ed, in the largest healthcare system in the world, ServiceNow, Hitachi, a lot of the large enterprises, some of the world's largest search engine company, the world's largest social media company, they're all moving to Mist. So it is time to look at a cloud-based option for you. So with that, Mary Kate, I'm going to turn it over to you, and we'll pause here.
Okay, great. Thank you. So thanks for everyone who stayed on. There's quite a few of you. Go ahead and ask some questions, and we'll get those answered.
Yeah, actually, you know what? While you're doing that, if you're wondering, what does Mist actually sell? We sell Wi-Fi access points, with full Bluetooth Low Energy antenna array built in. So we have a lot of BLE use cases we haven't talked about today, on a completely cloud-driven system, right? And if you're wondering, how does it stack up to your existing environment? You no longer need to deploy controllers in your data center, redundant controllers in your data center, redundant data centers to run those controllers. You don't need any of that stuff. You don't need a separate assurance system like Aruba Airwave Clarity or Aruba Net Insights or whatever. Sorry, I don't know why this keeps moving. And you don't need a Cisco DNA and blah, blah, blah. Passe. Those are all boxes you shouldn't be responsible to building anymore. And for location, you do not need an MSC or an Aruba location engine anymore. Everything should be in the cloud. You should be in the service delivery business. We should be in the operations business of the network for these types of services. That's our mission. So all of these services are available in Mist platform today, turnkey, without you lifting a finger. So Mary Kate, if there are no questions, I think I'm going to pause here.
Yeah, there's a couple of questions, but I think maybe we'll have our representatives reach out to answer most of them. I will just see, is our cloud National Institute of Standards and Technology and HIPAA compliant?
Yes, we are FedRAMP certified. We are in highly secure data centers that are federal approved. If you're outside of the U.S. or you have locations outside of the U.S., we have a GDPR compliant cloud in Europe as well, incredible amounts of security and penetration testing has been done. We are also deployed in some of the 3-letter agencies. So absolutely, the answer is yes.
Okay, and then I know that this is more than just a quick answer, but if you could just briefly touch on our location-based services. We have a request for that.
Okay, so location-based services, that's going to be a slightly longer conversation, but I'm going to show you just a brief overview. We're the first and only vendor, without a location appliance needed on-prem in your data center. We have, my screen is acting up here. We have brought in, Wi-Fi clients, unconnected clients, BLE mobile app users, BLE assets. So if you give employee badges with BLE, or you put, tags on your printers and scanners and stuff, you would be able to see them. And so we brought all of this together. For BLE, one of the coolest things we have done is we launched the notion of a virtual beacon. So you can actually launch a virtual beacon and basically say, hey, I want to do a message saying welcome to Mist, and you hit save and you hit save. So you no longer need physical beacons, because we actually are now able to do virtual beacons, and you can send engagement messages to all these guys, right? So that's a lot. There's a lot of very interesting stuff on BLE, and that will require a separate session on its own. So I will leave it at that, MC.
Yeah, no, that's great. And I did put a link for our BLE resources page on our website, so you can go ahead and take a look at that. And of course, we'll have somebody reach out who can really go through that with those of you who are interested. Okay, with that, I think we are well over time, so we're going to go ahead and wrap up. Again, as a reminder, if you are interested in a full overview demo, there are some links in the chat box there that you can grab, or we'll be reaching out. If you are interested in our free AP program, this is your first step towards getting that. So if you are an end user and you have a project coming up and you want to get some testing in, our reps will be reaching out to contact you about that as well.